Okay, in this video, we're going to go through the process of using the HP prime to do a Beer's law, linear regression, and some calculations involving it. So we have a sample problem here off of our practice sheet, and we're just going to use that for this demonstration. So to start out, we're going to enter our data, and we're going to go to the two variable statistics app. And there we're going to just put our data in. So let's see, so 0, 1, 3. Okay, so now we have our data in, and that was in the num format for this app. So now we're going to go to the symbolic format, and so our C1, that is, you can see that's our independent data at the bottom where it says enter independent column. So C1 is going to be our X value. And then in the second block, it has that C2 is going to be our dependent column or our Y value. So, but our Y value was percent transmittance. So we need to convert those numbers into absorbance values and do the plot with absorbance values for our Y values. So to do that, we're just going to make it do this calculation from the symbolic view. So we want it to take the negative log, okay, and then we want it to do C2, so you're going to use your alpha keys, so C and then 2, and then divided by 100, because that's the equation to convert percent transmittance into absorbance values. So I'm going to hit enter, and that's going to pop that up to there. So now the plot, my S1 plot, is going to be the C1 or concentrations in the x-axis, and in the y-axis it will have the absorbances based on the transmittance values that we typed into C2. So now I'm going to go to the plot view, and so there's my plot. If I hadn't been able to see the line, or if it looked like the points were all bunched up, then that's when we would hit the view key and choose auto scale, and that would give us, and so see how now we can see all of our points on there. So now we're going to go back to our symbolic view, and now you see in there we have that the data is linear and that it gives us our best fit line, the equation for our best fit line. And what we're going to do is we're going to use that line based on these standardized values, or these known values that we have. We're going to use that to solve for some unknown solutions. And so we want to copy that. So I'm going to do Shift and the view key, and that'll make the copy. And I'll get a little purple symbol that pops up, which I think with the delay on my little thing that you probably didn't see that, but you'll get a little purple symbol that indicates that it was copied. And so now what I'm going to do is I'm going to go back into apps, and this time I'm going to use the Solve app. Okay, and so I want to touch that, so it's going to open up in the symbolic view, which is what I want, and just in any one of these things here, which I'm just going to leave it in E1, I'm going to paste my equation. So Shift and the menu key does my paste, and I'm going to choose that last thing that I copied. Now, what you'll notice is it's down here on the line, and you'll notice that it doesn't have the y equals. So the solver needs an equation, so I'm going to add y equals to this to make it an equation. Okay, so I'm going to use the alpha key. So alpha and 1 gives me y. And then you'll see on the bottom row of tabs, the middle tab is equals. So I put that equals. And now when I hit enter, so now I have an equation up in there. Now when you go to the number view for the solver app, what you'll get is you'll get a screen that has a y and an x value. And from this screen, you're just going to plug in whatever value you have, and then you can get it to solve for the value that you want. Now, in the problem here, it's saying I want to know concentration of an unknown solution that transmits 85%. So I need to have the absorbance that corresponds to an 85% transmittance. So I'm going to get back out of this app and go back to the function app. Oops, there we go. And then go back into my number view. Now, sometimes if you're coding from any of the data apps, when you go back to the function numeric, it'll have like this little column of data in it. And all you have to do is just hit escape, and it'll get you back to your regular screen. So here I'm going to just do my conversion equation. So minus log, and I'm going to do 85 divided by 100, and then enter. So here is the 7.06 10 to the minus 2. That's my absorbance that I'm trying to find the concentration for. So that's my y value, and I want to find the x. So I'm going to go back with, and actually I can just take and copy that value, and then go back to the solver app, and we'll open that in the number view, and then I'm going to paste. Oops, okay, it didn't keep that. Let's go back. All right, well, I remember that it was 0.0706. Oops, hang on. Let's try that again. It pasted a thing in there, so let's get rid of that. All right, 0.0706 was the absorbance value I have. And you'll see as soon as I put that in there, then my cursor switched down to the X. And then in the lower right, where it says solve, I'm going to click solve, and then there is my corresponding X value for that. So a solution that is about 0.046 molarity will give you a transmittance of 85%, or conversely, an absorbance of 0.0706.